Well, on this one it should be, we have a b of 9 and an a of negative 3. So we'll put those negative 3's in there, and the b is 9 again. This is going to be negative 3 plus a negative 3 is negative 6. Squared is positive 36. This is 6 times a negative 3 is negative 18, so it should be an answer of 18. Everybody had this one. The answer is 13. Last one. R is 4 and S is negative 2. T equals R, so T is 4.
That's what I did right there.
What do you think that was?
I thought it was 1 and 2.
Oh my goodness. Well, the minus R, you have another 4, and then here's a 4, and then a negative 2. Just keep this 4. That's 0. Squared is 0, and times that is 0, so it's all gone.
And that's the only thing that threw me off, is because I thought that was just like a 1 and a 2, like 2 close together. So
Oh. Yeah, that'll do it if you stick a 12 in there instead of a 4. That'll throw it way off. So that's 16 and a negative 32. So that's where we come up with negative 28. Alright, so 4 with homework, 6 present, that would be 67%. Here are the answers. If you have any questions, we'll go over it after we finish. Number 1 is 4i square root of 5. Yeah, on this first one here, it should be plus or minus in there. I left that out. 2 is plus or minus 5i square root of 7. I can't remember if I said plus or minus on the first one. And on the third one, plus or minus 7i square root of 3. 4 is plus or minus 12i square root of 2. And number 5 is plus or minus 3i square root of 11. On the practice, you have to start with x minus 5 and then x plus 6. Multiply it out. X squared plus 6x minus 5x, or minus 30, equals 0. And simplify the middle to get x squared plus x minus 30 equals 0. What number do I multiply 6 by to get 30? 5. So that means x plus 3 must be equal to 5. So the answer is 2. This one is a new objective. Use complex numbers in polynomial identities and equations. And we'll get to the complex part as soon as we master the other. Know the fundamental theorem of algebra shows that it is true for quadratic polynomials. And the part of the fundamental theorem of algebra that we're looking at today, every non-zero, single variable, degree n polynomial with complex coefficients has, counted with multiplicity, exactly n roots. Now that sounds really weird. The example is much easier than what it sounds. Now you have to remember when I use the word roots that we're talking about the solutions. So if you factored out a polynomial, you do the opposite of each of these and come up with negative 3, negative 2. You have to remember that. When we say roots, we're looking at the solutions, and what these mean, that's where they cross the x-axis on a graph, which we'll look at later. So here's example 3. I want to create a polynomial of the third degree that has roots of 4, negative 3, and 2. Third degree means it's going to have an x cubed in it somewhere. It'll be the highest power. So before you had to solve it and get the answers. Now you get the answers and you have to go backwards to create the polynomial that it came from. Here's how you do it. If you have 3 solutions, then you need to set up 3 sets of parentheses, each with an x in it. And then from your solutions, remember when you factor out a polynomial, you flip the sign on the numbers to get the solutions. Well, you have to do that now to go backwards. So instead of putting in +4, you do -4, and then +3, and then -2. You can just write down the solutions and put 3rd degree. That's how I'm doing the homework. I'll say 3rd degree and then put 3 numbers in. So is everybody with me so far how I put this in here? Okay, so from that point, you're going to have to multiply the first 2 expressions out, here and here, by using the FOIL method, first outside, inside, last. That's x times x is x squared. X times 3 is 3x. And then shift to the -4. -4 times x is -4x. And -4 times 3 is -12. Now remember, that's in just one set of parentheses, and you still have x minus 2 out here to the right. Simplify inside that left-hand set so it's easier later on. 3x minus 4x is minus x. So now when you go to multiply by x minus 2, you have less to deal with. So when you multiply this by x minus 2, you're going to do x times x squared is x to the 3rd. X times minus x is minus x squared. And x times minus 12 is minus 12x. Now shift over to the minus 2 and do minus 2 times x squared is minus 2x squared. Minus 2 times minus x is plus 2x. And minus 2 times minus 12 is plus 24. And don't forget the equals 0. Now clearly you're going to have to simplify this, add your like terms together. You only have 1x to the 3rd. But you have a couple of x squares in there. Minus x squared minus 2x squared is minus 3x squared. And then minus 12x plus 2x is minus 10x. And you're just left with that 24 on the end. Your answer is x cubed minus 3x squared minus 10x plus 24 equals 0. Alright, so we need a second degree that has roots of -3 and 7. So, you need 2 sets of parentheses with an x in each. And what am I going to put in those parentheses?
X plus 3 minus 7.
Right, plus 3 and minus 7. Now what do I have to do? Yeah, FOIL method, multiply these out. X times x, x times minus 7. Now where do I go? We go to the 3, 3 times x, and 3 times minus 7. What do I do now? Combine like terms. What is negative 7x plus 3x? What is negative? It's how much? Yeah, negative 4x. And then the minus 21 stays along. This is your answer. So we need a 3rd degree polynomial. So we're going to have x plus 1, x minus 2, and x minus 5 set equal to 0. We're putting in the opposite of these. Multiply these two together to get x squared minus 2x plus x minus 2. And then go back and simplify that. These middle terms. x squared minus x minus 2. And now multiply by the x minus 5. If you multiply through by the x, you get x to the third minus x squared minus 2x. And multiplying through by the negative 5, you get negative 5x squared plus 5x plus 10 equals 0. So you have an x to the third. Negative x squared minus 5x squared is negative 6x squared. And negative 2x plus 5x is 3x. And then the plus 10 stays along. The bonus is 6x minus 3x equals 15 plus 12, so that's 3x equals 27. X would have to be 9. On the practice problem, it should be x plus 7, x minus 8. And when you multiply, it's x squared minus 8x plus 7x minus 56. Simplify the middle to get x squared minus x minus 56 equals 0. This should be negative 3x plus 2x equals negative 6 plus 1. So that's a negative x equals negative 5, but you have to divide both sides by negative 1 to get a 5.